Okay, let's go. Let's do reading of the have to go home. And then I over what's now. Sorry guys, I think I opened late today. I'm very sorry. I wasn't watching that time. Usually I watch. What are you doing, Arya, in school?
We're graphing radical equations and inverses.
Ah, I see. I see. So have they started cube root and cube?
Yeah,
I see. Have you started finding inverses? Composition of
yeah,
those?
yeah.
Sahil, what are you doing?
Uh, Wait, can I check?
Yeah, please. Parvini, what are you doing, ma?
I told you last class, we're doing the same thing still.
Oh, okay. Okay, that's good. So, have you done cube and cubic inverses, graphing cubic and cube root equations?
Me?
Have you already done or yet to do in school?
We did.
You did square root and square functions?
Yeah, I think we did.
Okay, I think you did. Okay, that's good to know. Okay. How about Dwani? Dwani, same thing as Arya, right? And Krish?
Yeah.
Okay, Pranav, the same thing, right? Adav, Pranav, Dwani, Krish are all the same thing, right?
Yeah.
Okay. Okay. So, okay. Shragvi, how about you, ma?
We're doing the same thing.
Same thing as them?
Yeah.
But you study at Plano Senior, Plano East, right?
Yeah, but yeah,
They're discussing the same thing? Okay.
yeah.
Interesting. Okay. Okay. Sorry, guys. My video is also as well not on. So let's go ahead. Okay. Last week we did some inverses using algebraically, right? Square. So let's see. Let's review that finding inverses, and after that, let's graph. You have to give me a minute, guys, till I get the. I'm sorry. 7, 8. 1 second, guys. Bye, guys. You have to give me a minute. Okay, guys, let's go ahead. Sorry, guys. How about this? Let's go ahead with this. Suppose if I give you f of x, see, I don't know where you are. Let's see on this. If I give you this, right? Would you be able to find the inverse of a function? In the sense, will you be able to, all of you? We have done inverses earlier, right? But would you be able to find the inverse of, I just need to know where we are and then proceed with this unit, guys. Can we try? Can we try with this one, guys? you find this too easy, based on that, I'll move on. Krish, good job. Krish, good job. Okay, so I write the F inverse as this, right? F of x is this, F inverse is this. Square root of. Really, Dhwani, is that right? That doesn't seem right. Okay, Pranav. That doesn't seem. Okay, some of you are doing, some of you are not doing. Arya, can I get your answer? No, I'm see. Oh, yeah, you have it. That is right, Arya. But the square root is applicable to both or one, Arya? Square root is applicable to both or one?
I don't understand.
Square root is applicable to both or just one of the factors? What I meant to say is, okay, this is given as this 0.5x square. Okay, I'll go ahead and do and you can tell me. So now change it, x equal to 0.5y square. So first step number one is that, and then step number two is to solve for y, right?
Yeah.
X by 0.5 will be equal to y square, y will be equal to square, this becomes 2x, right? Square root of 2x. So this will be f inverse of x. So here I asked you, the square root is applicable for just 2 or even the x I asked you.
Oh, both.
Yep, okay. So f inverse of x will be equal to square root of 2x. So you guys know this, but I have more questions here. Do you all know how to graph this, guys? Do you all know how to? Okay, first of all, what are the domain range of this function? Domain range of the inverse function. What I want you to know is domain and range of the original function is the range and domain of the inverse function. Do you know that? Domain range of the original function is the range domain of the inverse function. Am I clear? Do you already know that? I just need to know. I just want to make sure whether you remember that or do you know that? Okay. Now, yet another thing, if they are really inverses, right? This and this are inverses, right? In that case, the composition f of f inverse of x or f inverse of f of x equal to x. Have you heard about this too?
Yeah.
Parvini, have you heard about this?
No.
Okay. Okay, let's wait. Let's wait on that then. Let's wait on that. Dhwani, Arya, Adav, you have all heard about this, right?
Yeah.
Arya?
Yeah.
Okay, Shragvi?
Yeah.
Okay. Okay, Pranav is also new to this. Okay, wait, let me go back. Now, f of x equal to 0.5 x square, correct? Okay, just 1 second, guys. 1 second, guys. I have a hard stop. Okay, please hold on. Sorry, guys, I have no one around and there were some people at the door. Okay. So f of x is this. F inverse of x is this, correct? Now, if they are really inverses, right? f of f inverse of x will be equal to x. What is this? This is called the composition of f and f inverse of x. This is called the function composition. What is function composition? I think I have discussed that in class way back, but I really don't remember. Suppose let's stop here, go back to understand whether we know function composition and then come back. F of x equal to x plus 1. G of x equal to, so let's say x minus 1. What is f of g of x? See, what is function composition? You're putting a function g of x as the input to f of x. So basically, this is the input to a function, right? That g of x is the input, right? G of x is the input to the function f of x. So wherever you see the f of x is the outside function. So wherever you see f of x, you're going to substitute it with g. See, wherever you see the x in the f of x, the input, right, of the function f of x, right? There, you're going to substitute x minus 1 in the basement. There, you're going to substitute x minus 1. So I'm going to substitute x minus 1 instead of x. So what I'm going to do, f of g of x, meaning, see, the input has become g of x, right? So wherever you see the x, you're going to plug in the g of x. G of x was x minus 1, right? So that is going to be g of x plus 1. What is g of x? X minus 1 plus x. X minus 1 is g of x plus 1. So minus 1 and plus 1 goes off. So f of g of x equal to x. Any questions, guys? This is called the function composition. What is g of f of x? See, this is different from this. G of f of x means you take your g of x function, the input became f of x. What is f of x? X plus 1. So instead of x, you substitute x plus 1 minus 1. Again, that is also x in this case. It doesn't have to be the same. Am I clear with function composition, guys? Or you need more input? So basically, you are taking the function as input and providing that as the input to the other function. Whatever is inside is your input. Whatever is inside is your input. Make sense? Okay. So now this function composition, see, it can go both ways. You can take the inverse function, substitute f of x as your input, or you can take the original function and you can put your f inverse of x as the input. Both should be equal to x if they are really inverses. Can I move on? Now, how to verify this for our function? Pranav, are you following Pranav? Pranav K.
Yeah.
Okay. So how to verify this for this function? F of f inverse of x, I'm going to first try. What does it mean? I'm going to provide f inverse of x as the input to your original function. F inverse of x is here. This is your input. Wherever I see the x, I'm going to plug in this. So f of f inverse of x will be, this tells me that for your function f of x, f inverse of x is your input. So wherever I see the x's, I'm going to substitute my root 2x. 0.5 inside root 2x, the whole square. What happens here? 0.5, root 2 square is 2, x square is x square. 2 times root 2 is 2 times 0.5 is 1, right? 1. Okay, here this is root x the whole square. So basically 0.5 times 2 is 1. Then root of x square is x. So do you see f of f inverse of x is an x here? You see function composition when they are really inverses, right? Function composition has to be, function composition between the function and its inverse has to be x. Similarly, you can as well find this f inverse of f of x means you're going to choose the f inverse function as your original function. What is it? Root 2x. However, instead of the input becomes my real original function. So root 2 inside the square root, you get 0.5 x square. What happens? 2 times 0.5 is 1 x square. So that is as well equal to x. So f inverse of f of x is 1 as well. Make sense? Pranav, have we discussed function composition as a part of this class?
We probably did it a while ago, but I don't remember it as of late.
Okay, see, see, that's what I thought, but I don't remember. I have to go back, check, I feel. Okay, anyway. 1 second. Now, where is the sound? Can I erase this off? Now let's go ahead with proper square root, cube root. How about this? Now I'm going to give you this. You're going to find the inverse. Let's talk about domain, range, and more properties. Okay. F of x equal to x square minus 7. Can you find out the f inverse of x? Can you find out the f inverse of x? It's an easy one. F inverse of x. And then I also want to find out the domain. Domain of f inverse of x. See, this one is new. In this problem, finding the domain of the f inverse of x is new. Fine, let's see. See, module 12 is already done, right? 10 and 11 is what they're going to complete, right, Arya? Right, Arya or Ada or
No, 11 or 12. 11 and 12 is this unit.
11 and 12?
Yeah.
Come
I
again,
think
11
that
and 12.
we have a concept check on Tuesday. I think that's only this though. Like,
That's
I think
only on
it's
module
just
11.
like inverse and stuff.
Okay. When is it? When is your concept check?
Tuesday.
Tuesday. Okay, good. Okay, let's see. But let's see. I don't know. I want to look at square root, cube root. I don't think we'll have time. Let's see. Oh, wow. Okay, Krish, there is a problem. I'll tell you the problem. You have the answer correct. See, everybody is finding this correctly now. So now if you want to do this, right, first step is you're going to change. Finding inverses means you're going to change x to y, y to x, okay? Now, then what do you do? Solve for y. So x plus 7 will be equal to y square. So take square root on both sides. So square root of x plus 7 will be equal to y. So f inverse of x. So you all got this done, which is great. Sahil, are you following Sahil?
Yeah.
Okay. F inverse of x we found out. But you know, whenever you have square root, right, whatever is inside should be greater than or equal to 0. You cannot have a negative term there. It can be 0 or it has to be greater than or equal to 0. So what do? X plus 7 is greater than or equal to 0. X is greater than or equal to minus 7. See, that is a restriction on the domain.
Miss
You
Priya,
put a, Yama?
like as you said before, like the domain and range for the inverse functions are just the opposite of each other. Like the domain is the range, and
Yep.
like for this one, like the original function was the range was all real numbers. So wouldn't
Very
the
nice.
domain be all real numbers here too?
Oh, very nice. Yes, that is a very good question. Let's go ahead and plot it. Dhwani is asking, hey, I told you domain becomes range, range becomes domain, right? For inverse functions. True. Here, the domain, okay, for this one, right? That's the original function, right? That will be equal to x square minus 7 means this is going to x square minus 7, right? Yeah, x square minus 7 is this. So basically, your domain is all real numbers. Your range is what? 7 and above, right? Minus above equal greater than or equal to minus 7. Correct, ma?
But isn't negative 7 a x value?
Oh, I'm sorry. I'm confusing, huh? No. What are you saying? This is all real numbers, right? Domain.
No, the range isn't -7 the x value.
-7 is a y value, right? No? Oh, x square minus 7. So it's up, huh? No, it went down. What is that, Dhvani?
No, I got it.
So it's greater than or equal to 7. So one thought about this, guys. I really want to bring up Dhvani's question. Dhvani is asking, see, let's say I'm little going off this question. Okay, I'll come back to that question. Y equal to x square, right? Y equal to x square. Okay, this is our parent function, original function. This is f of x. Okay, I'm going to write the domain and range here. This one I should have told you before itself. Since she brought it up, I want to bring it up. This is all reals. Okay, range is y is greater than or equal to 0. Any questions still here? You know this. You all know this. Okay. One thing is, for any inverse function, algebraically, these are the steps. Inverses, when you want to find algebraically, this is the step. Change y to x, x to y, and then what do? Solve for y. That is finding inverses algebraically, and you have to make sure that f of f inverse of x is always x if there is an inverse. It is always equal to x. This is all algebraically you're doing. But in the graph as well, you can do. You know what you can do for finding the inverses directly from the graph? There is a quick way. Okay. So here I want to find the inverse of this. How do you do it? If it is algebraically, you would go ahead and put x equal to y square. Then take square root on both. Y equal to square root of x. So now this is algebraically, I know that, okay, y equal to square root of x. But the problem is, if I write the domain and range directly from here, hey, it should be the other way, right? So domain, so here x has to be greater than or equal to 0. Range should be all reals. Is that what it is? We don't know. Let's see. There is going to be some changes here. So x is going to be, so when it is square root of x, right? Again, we can't have a negative number here. Do you see? We can't have a negative number here. So there is a restriction. In the sense, what happens to y values? It should also be greater than or equal to 0. That means what you're doing, you're going to restrict the domain. See here. Problem is, here x greater than or equal to 0 is correct. Range, when you look at this, right, you cannot have a negative number at all. If you plot a graph, this is 0, 0, 1, 1, then I will have 4, 2. So basically, if you plot 0, 0, 1, 1, 4 is a 2. 4 is a 2. 4 is a 2 means a little back. See, the graph goes like this. Square root graph goes like that. So when you look at this graph, right, it's a little different. What is different? This is correct. X greater than or equal to 0 is correct. But y is not all reals. That is where all reals means everywhere it should be, right? Across the board, it should be on the y-axis. No, it is only greater than or equal to 0 is the right one. This is incorrect one. As Vani brought up, it should be exactly opposite, right? No, it is not. Why? There is a restriction on the domain. I am going to restrict the domain. Why should I restrict the domain? Why should I change it to y greater than or equal to 0? I can just copy from the domain, right? No, I'll tell you why. Here, we are going to find out graphically. I'm going to find the inverse graphically now. Okay, when I want to find the inverse graphically, you know what I do? I draw a line y equal to x. This is a line y equal to x. Now, I consider that line as my mirror. I consider that line as my mirror. So this part, right? Mirror means it has to be reflected. I draw this. Guys, please, I split my original graph into parts. This is a reflection. So this is my graph. Okay. Next one, this piece, right? This one is here. Okay. This one is here. This is my new graph, inverse graph. Again, there is one more piece which I have not done at all. This one, which one? 1 second. So this one, let's see. This one, right? How can I reflect it on the line? That becomes this. So now my inverse graph is a little different. Do you see my inverse graph is this? You see f inverse of x is this function. Do you all see? Now f of x was a function. It passed the vertical line test. F inverse of x, is it passing the vertical line test? No, f inverse of x is no longer a function. See, vertical line test, there are 2 points on the graph. So f inverse of x doesn't pass the function test itself. It is not even a function. So f inverse of x, when you graph it, is not even a function. So that is when you need to decide to make it a function, meaning your f inverse of x has to be a function, right? So you know what you do? Purposefully, you restrict the domain of the original function. You erase the bottom part. The bottom part, where was it valid? The bottom part was valid when you drew the f inverse of x using the graph. So you have to delete this. You have to restrict some pieces of the domain. If you write it as all reals, it will be for all reals. This u is not even a function. So you know what happens? You are erasing the bottom off and you're retaining only this. So whenever you graph your inverse of function and it is not a function at all, that is when you cannot copy the domain to range, range to domain, but then you restrict your domain to make your inverse a real function. Dhwani, does that answer your question?
Yeah.
Now, do you see you cannot write all reals, but then see x values from 0 to infinity, right? In the original function. That's what you're maintaining in the original. This, see, when you look at the main function, right? Original function given, this is the only part you're using. You're completely deleting this off. Then only your inverse function is a function. So you are deleting all domains that were negative values. So that's why your range becomes y greater than or equal to 0 in the inverse function. Parvini, are you following? Parvini, did I lose?
Oh, yeah, I was nodding.
Oh, you're not. Okay, I didn't see you, ma. Okay.
Sorry.
Okay. Dhwani, did that answer your question?
Yeah.
Okay. So if you graph it, how to graph the inverse function? You draw the line y equal to x, treat it as a mirror. Treat it as a mirror and your original function, you can cut it into part. Then only you'll get the proper function. This part is reflected like this. This part is reflected like this. This part becomes this. Make sense? So if you cut your original graph to parts, it's easy to graph the inverse function anytime. However, sometimes your inverse is not a function at all. It is not passing the vertical line test. Remember that we learned in 7th grade or 8th grade. It's not even passing the vertical line test. That is when you have to erase a part of your original function. The domain, you have to restrict it and make your inverse a real function. See, this is the original graph. I reflected. This is my inverse graph. See, so this is the square root function. This was the square function that is restricted. Make sense? That is when you cannot copy domain to range, range to domain. Okay. And when you do this, you restrict your domain and properly write your domain and range for the inverse. Can I move on? So here, this was one. Square root, right? Always you will have restrictions in the domain because if it is a square, you can have anything for the range. Whereas a square root, when that range becomes a domain here, it should have a restriction. How to find the restriction? Whatever is inside the square root, put it greater than or equal to 0, solve for x and tell the restriction. Adav, am I making sense?
Yeah.
Okay. How about this? Let's try this one, guys. Okay. I want you to be able to plot, but I think it's too soon to plot. Okay, why don't we plot this function itself? F of x equal to x square minus 7. So this one, right? We found out f inverse of x equal to square root of x plus 7. Was it x plus 7? I don't remember. Yeah. X, yeah. So now can we plot this? I will plot it, please. If you already know it very nicely, I can move on. But if there are some people who don't know, it's easy for me to plot. See here, this one is x square minus 7 means this is 7 down. 1, 2, 3, 4, 5, 6, 7. I'm not going to put tables, guys. If you want, you can put tables and see. Okay. So this is your original function, right? You know what? I want to graph it properly. This one is a point, and then put this is equal to 0, y equal to 0, if I put, right, x is equal to square root of 7, square root of 7 now 1 point something. Okay, so it's a very narrow graph. I feel square root of 7 is what? Square root of 4, 2, square root of, it's between 2 and 3. So basically it's between 2 and 3, square root of 7 is. So this is your graph. I'll have at least 2 points. Okay, now the problem with f inverse of x is what? Square root of x plus 7. So can I have x equal to 2 means it's a 3. 2 means it's a 3. Okay, if I put a this, right, x can be what? X can be, okay, let me put more points. X can be what? I want this to be a square. That's what I'm searching. So x can be 3, minus 3. If it is a minus 3, right, it's still a 2. Okay, now I'm going to extend this. 4, 5, 6, 7. If it is a 7, it's a 0. So see the graph, guys, what I'm getting. Am I making sense? This F inverse, Pranav, K, did you get it?
Yeah.
Shragvi, did you get it?
Yeah.
Okay, now I'm not going to plot it straight with points. Okay, let me erase this off. Let's do the graphical way of finding the inverse. Okay, let's do the, I want to experiment too. Meaning, see, if you don't have time to experiment at school, right? Here, if you experiment and learn, you'll never forget it. Okay, let's see this one. I'm going to draw for this one. This is my inverse, right? I'm just cutting it into pieces and finding my inverses. Okay, for this piece, right? Can I draw the inverse like this? Makes sense, right? Guys, are you with me?
Yeah.
So this is your point. And now for the next piece, right? If you're not with me, immediately tell me. This piece, right? See, from here, I have to go touch the 7 point. Make sense? And then for this one, see, it is starting at that point, going to a 2.3. So it should come to a 2.3. Okay. Now, what is the piece that's missing? I don't know. Oh, the last part. What is this piece? This one. That one starts from here and goes straight. You see, guys? This is your f inverse of x. When you plot it graphically, this is your f of x. F of x is this u. Sahil, are you with me? F inverse
Yeah.
of x is this one. But the problem is this a graph? Is this a function? Literally, it's not a function. So I have to erase. Which part can I retain in my original function? This part I cannot retain. Meaning, in the f inverse of x, I cannot retain this. How did this come? What was reflected to get this? Basically, this piece. Which one? The left side piece. This got cut off, so this one I cut it off. That is where the restriction came, x is greater than or equal to minus 7. Make sense, guys? For the domain of the inverse function. So the final graph of the inverse function is this. Any questions? Any questions? There are two ways of doing it, okay? Draw y equal to x line, make it as a mirror, reflect the original graph on that. Okay, if it is too difficult to follow, split it into parts. Each part, small part, you can split it and then reflect it. It becomes easy. If that is difficult to follow the algebraical method. Okay, in the algebraical method, what I would want you to make sure is f of f inverse of x should always be equal to x. Then only the inverse exists. Or f inverse of f of x should always be x. Function composition between the inverse and its own main function is always x. Okay. So let's move on with another. How about this? Okay, how about this? We'll do one problem. Now, I'm giving you the energy function as 4v square, where E is in joules. Okay, of an 8 kg object. 8 kg object traveling at a velocity v meter. Traveling at v meters per second. Okay. Now, okay. Estimate the velocity required for an 8 kg object to have energy equal to 60 joules. Can you do that, or do you want me to do that? I have given you the equation that works between energy and velocity. Velocity is your input, energy is your output. Energy is dependent on velocity. It's given by E of V will be equal to 4V square. I'm asking you, basically these are problems on inverses. Estimate the velocity required. You have to solve for V basically, that you convert it to a function. You can find the inverse function literally. So from that function, estimate the velocity required for the 8 kg object when the energy is 60 joules. That time, if you find the inverse, your input becomes 60 joules. Can you try? Can we try on this one, please? If you're stuck, let me know. And from 14th, you have a holiday, right? Meaning FISD's holidays when, guys? Just let me know. FISD has your spring break. Spring break, is that what it is called? When is FISD spring break? Now, when is your spring break?
What are you asking me?
Arya, I'm sorry, Arya. Today I started late, Arya.
Miss Priya, are you asking me whether
Yes, Pranav, okay, yes.
I'm in Prosper ISD, but my ours is in 2 weeks, including this week. So yeah,
Oh, I see. So you're not having your break from 14th?
but no, yeah, it is from the 14th. It is from the 14th.
Okay, makes sense. I'm stuck. Okay. Yeah, absolutely. Guys, how are the others doing? I really want to know. E of V means E, energy is independent value, the Y value, which is dependent on V, 4V square. So V is considered as input, E is considered as output. Any questions here? Any questions here? Now I'm going to find the inverse. So if I write it as a function, I will write it as, let me write it as f of x will be equal to 4x square, I'll write it. But instead of that, they've given E of V will be equal to 4V square. Now I have to find, see, if I want to estimate the velocity, I should have a function for velocity. I have only a function for energy. So how to do this? I have to find f inverse of x. Basically, f inverse of x means I will solve for V equal to. Okay, that means V, where energy will be your input. Basically, I have to find f inverse of x. How to find f inverse of x? I told you, right? E will be equal to 4V square means change V to E. V 4E square. Now, take square root. Before I take square root, right? No, I'm skipping steps. So, V by 4 will be equal to E square. Take square root on both sides. It will be square root of V by 2 will be equal to E. Any questions here? Or I can write this out as, or, okay. Did I do the right thing, guys? 1 minute. E will be equal to 4V square. So I just wanted to solve for V. 1 minute. Oh, actually, See, this one you can directly substitute. 1 minute, guys. Mhm. Okay, see here, you don't even, okay, see here, when you solve for the inverse, right? You're solving for, okay, in this case, right, they're just asking, estimate the velocity required for the 8 kg object to have E equal to 60, right? From here itself, you can derive V square will be equal to E of V by 4. They have given, I did not properly notice this. So 60 by 4, right? V square will be equal to 60 by 4. It is a simple one. V will be equal to 30 by 2. V will be equal to square root of 15. So basically, when you substitute, when you substitute the input, when you substitute the energy 60 joules, right? Automatically, you get V will be equal to square root of 15. What is square root of 15? It's almost equal to 3.9 meter per second. Directly, you don't need to find inverse at all. You don't have to find this at all because you don't need this. Directly, they have given you this. Directly, they have given you the entirety of this. So you can directly substitute and find out the V. Can I go ahead? You don't need this at all. Because when you solve this, right, you're only getting, you're not getting what you need. So here you just need to find for V, just go ahead and substitute E of V will be equal to 60. You get V square. You can solve for V directly. Can I move on? Can I move on? Let's try. Can I move on, guys?
Yeah.
Shragvi, Shragvi, did you get that?
Yeah.
Okay. This is the area of a circular object. Okay. Now find R of A. Find R of A. And also, this is number one. See, okay, here you have to do what, guys? Here you have to do what? You can directly find R of A. Literally, you're going to solve for R. Solve for R because here there's no need to find inverses. And also find if radius of a circular object, if area is equal to 40 centimeters square, right? Find R. R of 40. So from here, I can do this, guys. Next one you can do. Directly, you can do this. So A of R will be equal to pi times R square. Now, A of R by pi will be equal to R square. Now, take square root. So basically, R will be equal to A of R by pi, right? So A of R is what? Area is, they've given, right? So now we have come to find out that R, when R is the input, I can say it like this. A becomes the input by pi. I can substitute A will be equal to 40. So R of 40 will be equal to square root of 40 by pi. Make sense, guys? Can I move on? How about a square root function? I would like to solve for a cube root function. Shall we go ahead? Can I erase this? Pranav V, are you on board?
Yeah.
Okay. Dhwani, that is good, ma. Shragvi, that is good. Nice to see your answer. But Adav, you did not take the square root, I think, right?
Yeah, I think so.
Okay, how about this? This is a cube root function. Same thing applies. Find the inverse means you go ahead and change. Find the inverse means you go ahead and change x as y as x, and then find. There you found out square root. Here you will have to find cube root. Maybe one I'll do, guys. Next one you can do. I'll do this one, please. So basically, you're given y will be equal to x cube minus 9. Now, change y cube minus 9 equal to x. Now, y cube will be equal to x plus 9. Here, there is a cube, right? So, take cube root. In that case, you need to write 3 because if you write it like this, it's always square root implicit. If you write it like this, it is implicitly 2. Okay, so you have to specify that you're taking cube root. Make sense? So now this y will be equal to cube root of x plus 9, which is f inverse of x will be equal to cube root of x plus 9. Now, do we have restrictions in the domain on this? Who can answer this question? Amma Sahil, you forgot to convert x to y to x. Did you see that?
Yeah.
Okay, so now, can there be restrictions in the domain for this or no? Guys, whatever you think, please interact and
No.
say. Yeah, you don't, yeah, why?
Because the original function didn't have restriction for domain.
Correct. But when it is square root, we had restrictions in the domain put on this so that the range was restricted here, right? So do
It's a
we have a
cube root function, that's why.
Exactly. So it's a cube root function, meaning, see, if it is a cube root, right, -1 times -1 times -1, -1 does have a cube root. -8 does have a cube root. Negative numbers do have cube roots. Okay, so when you take cube root, there will be no restrictions on the domain like what we did, meaning a parabolic curve, when you wanted to find the inverse, you had to have it like this and you had to delete the bottom portion, correct? This one was f of x equal to x square original function. F inverse of x will be equal to square root of x. Square root of x, whatever is inside has to be greater than or equal to 0. You had to restrict it because you erased this bottom half. Whereas for a cube root function, let's plot the curve first. How do you plot it if you're given some function, right? And if you don't know, I have seen algebra 2 kids who do not know how to plot this function. Okay, so I'm repeating for them how to find the original function graph. Now for the cube root function, okay, 1 second guys, I have somebody at the door. I don't have anybody at home. Hold on, please. So here when you think about it, right? -3, -2, -1, 0, 1. Just plug in the values, guys. I'm just drawing this function's graph and this function's graph. So I'm going to plug in values. If you don't know anything about graphing, this is the easiest way to graph. So -3, when you plug it in here, it's going to become 27. -9 is going to be what? Oh, sorry. -3, right? 3 3s are 9, 9 3s are 27. 27 minus 27 minus 9. So that is going to be 36 minus 36. Okay, -2 if you plug in there, -8 minus 9, -17. -1 if you plug in, -10. 0 minus 9. Then 1, 1, 1, 1, -8 is -8. So you're getting only one part of the graph. So better go up a level. 5, 20, 5, 5 is 25. Ah, that's too much. Let me do a 3. Okay, 3 will be 27 minus 9 is going to be 18. So we got the positive part of the graph. So our original graph is going to be -3 is going to be a -36 somewhere here. -2 is a -17. -1 is a -10 maybe. And then 0. What? 0 is a -9? Am I making a mistake somewhere? 0 is a -9. Oh yeah, 0 is a -9. Okay. Makes sense because the cube graph, right, came down by 9. And then 1 is a -8. Okay. And then you have 3 as 18. 3 as 18. So basically your graph became like this. Does it make sense? A cube graph represents a chair. What is the parent cube graph? Parent cube graph is this one. Make sense? parent cube graph is this one. It passes through the point 0, 0. Because of this -9, it came down by 9 units. This function came down by 9 units. Any questions here? Now, how to reflect this? Graphically, how to find the inverse? I showed you how to find the inverse algebraically. But how to find the inverse graphically? Let me please erase the original parent function. Otherwise, it's so confusing. So let me go ahead and practically let me draw the y equal to x function. Okay, I'm going to redraw the graph, guys. So this graph was like this, right? It came like this, like this, like this, like this, 9. Went through like this. It is a chair. It is a chair, but at 9. So when you want to reverse, when you want to find the inverse, right? You know what you do? You have to draw y equal to x, reflect every piece of graph. This gets reflected like this. This one, right? It has to go to -9. So you see, and then see, it goes like this, right? From here on, it goes like this. So let me plot it again for you guys. I'm not very happy the way it came through. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So basically your original function came like this, right? This is -9. So this was x cube -9. So when you reflected, right, what happened? It's very easy to find using reflection. So this one, this part got reflected here. This one, right? This entire part is there, right? This one is this piece. And then it bent down like this. Do you see it? So both the functions are correct, meaning both are really functions. This one was, what did we say for this one? X cube root of x plus 9. Now, when you think about these two graphs, right? This is your f inverse of x. This is your f inverse of x. This is your f of x. This one is your f of x. Now, I told you, right? If they are inverse functions, what should they obey? F of f inverse of x equal to x. So, I will take my original function. Let me take my original function, x cube minus 9. But x was the input of that, right? Now, I'm going to change it to cube root of x plus 9 as my input. That is substituted instead of x. So that the whole cube minus 9. So this cube will become 1/3 rational exponent, right? So they get cancelled. As a result, this becomes x plus 9 minus 9. This goes off, see, x. F inverse of f of x, how does it change? Let's do. F inverse of x, what is the function? This one, cube root of x plus 9 I'm writing. However, instead of the x which was the input of this function, I have to substitute x cube minus 9. X cube minus 9 plus 9. When you take cube root, this and this goes off. Cube root of x cube will be x. Make sense, guys? Am I making sense or is it hard? Pranav, are we on the same page?
Yeah.
Okay. So this graph, again I'm repeating, this graph is a cube root function. Cube root function. Okay. Whereas my original graph, right? This is a cubic function. Okay. Both when you see, right, nicely they are getting reflected. Did you see on the x equal to y line? Graphically, that's the best way to draw your inverse functions. Algebraically, you have to change y to x, x to y, and then solve for the other one. That is f inverse of x. And then function composition should always be equal to x. And Wherever you are cutting down, meaning in case of square roots, you will have to restrict your domain. Square functions won't have restrictions, but square root, you will have to restrict the domain of the parent function. So the range of the inverse function will be restricted. Any questions? That won't happen in cube root. Why? Because cube root of -8 is -2. Cube root of -27 is -3. Cube root of negative function. Yeah, ma?
This applies for any even exponent, right? For any
Come again.
so this
Come.
like the domain restrictions still apply to every graph with an even exponent?
Correct.
Two.
Correct. Domain restrictions does exist for any positive, for any even exponents. Very nice. Very nice conclusion. Because why? Because fourth root or the second root of a negative number cannot exist. Completely makes sense. Very nice. Nice conclusion, Pranav. Can I move on? But honestly, guys, you won't be asked to draw quartic. Quartic means x power of 4. Quintic, please, this and all you should know. Quartic, you won't be asked to do. This is pintic, I think. Pintic or pintic, I think. So you won't be asked to draw these two graphs at the level of algebra 2. Okay. Quartic, pintic, you won't be asked. Dwani, did you understand, ma? There are no restrictions. Correct. Your domain was correct. Guys, can I stop here and ask you to do 11.1 exercise and maybe 11.1 you can do now. Having said that, 11.2 you cannot do all. So 11, okay, I'll indicate the page numbers you can do. Next week we'll try to complete the module 11. Okay, guys. Can I stop with this today? Yep. Good luck for whatever exams you have, guys. You should be able to graph the functions, take the inverses. But what you can't do right at this point is, given points on the graph, you don't know how to write the equation of the function. I will discuss that next week, guys. Given the points, how to find the equation of the graph is something you can't do yet. That I'll do it next week. Any questions? If you have any questions, stay.
Bye, Miss Priya. Thank you.
Bye, guys. Sitara, did you have any questions? Sitara?